Hey everybody, it's Miss C, 4th grade teacher at Syracuse Academy of Science and Citizenship Charter School. Today we're continuing with learning about waves. So last week we learned about waves and how they affect objects. We watched a video on how waves, when they're big, will collide with objects and they'll move them around a lot. They will give them more movement because they're transferring that energy to them. And we saw that when there were smaller waves in the dish, the rice that we put in there didn't really move a lot. Sometimes it was just a little wave and the rice would maybe move just a little bit, but it wouldn't hit other pieces of rice in there. So we know that the size of a wave affects the movement and it affects the objects around it. If there's a bigger wave, it's going to collide with objects and it's going to move them a lot farther. So today we are learning about earthquakes and the types of waves that travel through the earth. These are called seismic waves. Seismic waves. So we see this picture right here, and this house looks like it is toppling over. The foundation is totally crumbled. And our question today says, have you ever experienced an earthquake? What do you know about the damage that earthquakes can cause? So I will get rid of that, and I will go down here. Actually, up here, there are more pictures. So we have a video here. And this is what happens during an earthquake. So watch the things on the shelves. So we saw everything fell off the shelves, almost everything. The plant was shaking. Like it was just very, very strong. Those waves had to be really strong to travel through the earth and to be able to shake things like a house, to be able to make a house like the one in the beginning that we saw collapse, to be able to knock down this bear, to be able to knock down these boxes, these cups, to be able to move these plants and shake just this entire house. So those are really, really strong waves. So what we can do is we can do research in our area around the world on the website called the United States Geologic Survey, the USGS site. I'm going to do that really quick. So I'll open up the United States Geologic Survey. It's the top one, Science for Changing the World. And at the very top, I can type in earthquakes. You see that I did this before. Just pops right up. And I want to click the very top one because this gives us the latest and historical, latest earthquakes and then historical earthquakes. So there's a record. It's really cool because here we can see all of the earthquakes that happened today. So it shows us a map, and if you click on each one, let's see, it should, yep, you click on each one, it'll highlight it in green to show you where it is. So this is also a really good way to find out where places are geographically. So we have Puerto Rico is right down here. We have Mina, Nevada, which is right over here. You can also zoom in. So you can click the zoom in arrow and zoom in on it. But what's even cooler is that this shows us when and where these earthquakes were and their magnitude. So they are recorded on a type of scale called the mercantile scale, which records the vibrations and how strong they are. So the strongest one that happened today, let's see, we have a 4. See if we have anything bigger than a 4. A 4.7. Okay, so in Haiti today, there was a 4.7 magnitude earthquake. And if you want to see where Haiti is, it's right here. You can also do the opposite and click in the dots and it will highlight them on here for you. But so we know that the biggest one was in Haiti today and it was a 4.7. And then if you click it, it gives you all of this information, which is really, really cool. let's go back to our lesson today. So if you want to do that, feel free, go to the USGS site, type in earthquakes, click the top one, shows up, and you will be able to see that. So our question, think of what you already know about earthquakes and the damage they cause. Write questions you have. My question is, how big can an earthquake be? So we are learning about seismic waves today. Seismic waves are the waves that travel through the earth that cause earthquakes. So like we just watched in that other video, in this video we are going to see the seismic waves open up the earth. I'm gonna make it a little bit bigger. So we see that it's shaking and it's shaking, and we see, whoa, this huge crack in the earth. It's getting bigger and bigger. Wow. I think we should watch that again. So it starts, just a regular. You see how much the camera is shaking. And now we see this really big crack. See this crack getting even bigger. Wow. So those are seismic waves that move through the earth, and they cause the earth's crust to move. And it pushes nearby parts of the crust and creates these waves. So these waves are called seismic waves. So for each type of seismic wave, we are going to explain in pictures or words how the matter moves. So one of the things that we can look at here, let's see. Okay, here we go. So here is a fun thing that you can do with your friends, or you could do with your family members to help you remember the different types of seismic waves. So we are going to model them. So the first one is where you see these children here, you would line up 4 people in a row, and one person would gently push the other, and that person, when they felt it, would push the other, and then that person would gently push the other without pushing them on the ground. So you see that this wave moves kind of almost in a straight line. And so we have the crest and the trough and the motion of the matter and the direction of the wave. The direction of the wave is just pretty straight. So that is the first seismic wave. Our second seismic wave is called an S wave, and this is where we see that the motion of the matter goes kind of curves like an S. So in order to model this one with your friends, you would line up at all 4, and when one person jumps, as soon as this person feels them come back to the ground, they would jump, and then so on, creating this kind of S motion. And again, the matter is still moving from left to right. And then in this model, our third wave, you have your 4 friends here, and one person would kind of move in a circle like this. See how he bends down, he moves his hips a little in a circle, he comes back up. As soon as he comes back up, this person moves with him, and then everybody kind of moves to the side like a wave. So the motion of the matter it's still moving, the direction of the wave is still moving left to right straight, but the motion of the matter is moving more in a circle here. So we have our first wave, our second wave, and our third wave. So we now know that there are 3 different types of seismic waves. How are they similar and how are they different than each other? That's what we're going to talk about here. So our first wave, I am going to say, see if I can type here. I'm going to say that the first wave moved in a straight line. The matter moved left to right. Our second wave, now you could do anything here. You could draw a picture, you could write, but here I'm just going to type because this is what is easiest for me. For the second wave, this was our S wave. The matter moved left to right, but first traveled up and down. So that was where we saw that this wave was more like this, where this wave was more moving left to right, and it kind of just pushed. Remember, I'm just going to use arrows. So we had the force here, and then the next person would push, and then the next person would push, and then the next person would push. So those are my arrows. And then our third wave, the matter moved in a circle as the wave moved left to right. So that was where we saw that one person, that first boy, he would, let me get rid of this. He would move himself like this, and then he'd bring it up, and then the next person would kind of move almost in a circle also. But then they would push each other. So the first wave is called a P wave. The first seismic wave that arrived is the primary wave. That's why it's called the P wave. The second seismic wave to arrive is called a secondary wave or an S wave. And then the third seismic wave to arrive is called a surface wave. So it says here, think about the types of waves you learned about earlier in this unit. Water waves, waves on a string, and sound waves. Remember that scientists categorize waves by how matter moves as the wave travels through. Compare each seismic wave to the other examples of waves. How does matter move in each type of wave? Drag and drop each wave type below to the seismic wave it best matches. Okay, so we know that our sound waves are our P waves because sound moves out in a forward direction. Our S waves, or secondary waves, are like the waves on a string as we move them together and we coil them. And our water waves are like the surface waves. So the waves on water moves on the surface.